In this lecture, we will learn about lists in Python. A list is a type of collection. It is a way to group values in Python. We use lists to group related data. Let's look at how we use lists in Python and some of the built-in operations we can perform on lists. Let's create a list. We will call it numbers and store the numbers 1, 2, and 3 inside of it. The syntax for a list is that it starts with an opening square bracket, then comes the list elements, and finally comes a closing square bracket. To add an element onto the end of a list, we can use the append function. For example, if we want to add 4 to the end of the list, we can just type numbers.append 4. To see the list now, we will use the print function and print out the list of numbers. The count function allows us to see how many times a certain element appears in the list. For example, if we want to see how many times the number 1 appears in the list, we can use the count function and pass in 1. Let's print this number to the console so that we can easily see it. To get the length of a list, we can use Python's len function. Obtaining the length of a list is a very common programming task, especially when we want to iterate over the items in the list. For this example, let's use the len function and pass in numbers, and print the result to the console. As you can see, 4 was printed to the console since there are 4 elements in the list. 1, 2, 3, and 4. To reverse a list, we can use Python's reverse function. We will type numbers.reverse to reverse the list. Note that this statement will change the actual numbers variable. If we print out the list, you will see what I mean. Even though we did not save the result to a variable, the list was reversed, and that reversal was still saved. We can remove all of the elements of a list using the clear function. Let's call the clear function on our numbers list, and then print out the list to the console. We can tell that the list is empty because an opening and closing square bracket with no elements inside of them was printed to the console. Let's give our numbers list some more elements. We will create a new list with the numbers 4, 5, 1, and 0. To sort a list, we can use the sort function. Currently, the list of numbers we made is out of numerical order. To easily sort this list, we will use the sort function. Then we will print the numbers list to the console to see the result of the operation we just performed. To remove an element from the list, we can use the remove function. This function accepts a parameter of the index of the element in the list that we want to remove. For this example, we will remove the first element from the list, 0. To do this, we will use the remove function and pass in the index of 0. Note that 0 that we pass in is the index, not the element. I know it may be confusing, since in this case 0 is both the value and the position of the element in that list. To see the result of the removal, we can print the list of numbers to the console. Notice that the elements are now 1, 4, and 5, since the element 0 was removed from the list. If we want to remove the last element of a list at any time, we can use the pop function. Pop will simply chop off the last element of a list. Next, we will print out numbers to the console. Note that the only elements in the list are 1 and 4, since we popped 5 off of the end of the list. We can use the index function to get the index of an element in the list. For example, we can use this function and pass in 1 to get the index of the element 1 in our list. When we print the result to the console, you will see that 0 is printed, since this is the position of the element 1 in the list. We can use the insert function to insert an element at a specified index into our list. For example, let's add the element 9 at position 0 to our list. This means that 9 will be the first element in our list. To do this, we will use the index function and pass in the first position, 0, and then the element value, which is 9. When we print out the list to the console now, you will notice that 9 is the first element in our list. Recall that we can iterate over the elements in a list using a for loop. For example, we can iterate over our numbers list and print out the value of each number in the list. The syntax to do this would be the following. In this example, the variable I is the number for the iteration we are currently on, which is essentially the index at that point. We can use the range and len functions together to go through all of the items in the list. When we print out a number, we reference the list name numbers and use square brackets to tell Python that we want the element at index I. Let's look at another example of using a for loop. In this case, let's obtain a sum of the values in our list using a for loop. To do this, we can keep our existing for loop, but make a few modifications. First, above the for loop, we will initialize a sum variable to a value of 0. Inside of the for loop, we will add to the sum variable the element at position I in our list. The plus equals operator in Python is very convenient, as it allows us to add and set our variable all in one statement. Recall that the syntax for referencing the element at position I is numbers square brackets I. Finally, outside of the for loop, we will print out the sum to the console. Note that we want the word sum with an equal sign to come in front of the value. This means that we will need to use the str function to convert the value of our sum variable to a string. When we run this code, you will notice that the sum was printed to the console. Note that a list in Python can store more than one type of variable inside of the same list. For example, it is perfectly valid to have a list that stores an integer, a string, and another list. For example, for this example, let's create a list called mixed list, and we will store a string, an integer, and another list inside of it. Having a list inside of a list brings me to my next point, and it is actually a fundamental concept of computer programming. When you have a list inside of another list, it is called a two-dimensional or 2D list. This concept will play a huge role when we create our Tic Tac Toe application in a later hands-on lecture. 2D lists are a great way to represent matrices or grids. Let's look at an example of how we can create a 2D list and access the elements inside of it. We will create a 2D list with 3 rows and 3 columns. Essentially, it will be one big list, with 3 small lists of 3 elements. So how exactly would we go about printing out a row from our 2D list to the console? Say we wanted to print out the first row to the console. To do this, we can print out element 0 of our two-dimensional list. It gets a little trickier if we want to print out one of the elements at a certain row and column in our list. For example, let's say we wanted to print out the 0 in our list, which is the first element. It is located at row 0, column 0 in our 2D list. To do this, we can use indexing as we did earlier, but use 2 square bracket groups. The number inside of the first square brackets is the row number. The number inside of the second square brackets is the column number. When we run this code, you will notice that 0 is printed to the console. There is a programming technique used with 2D lists that is a bit more advanced. Don't worry if you don't get it at first. We will get some more practice with it in the hands-on Python section. This concept is called the double for loop. Essentially, we can use a for loop inside of a for loop. The 2D list is a list of lists, so to iterate over the elements of a 2D list requires a for loop inside of a for loop. First, we will iterate over our 2D list the same way we have been doing at other points in this lecture. Next, we will iterate over the list at index I of our two-dimensional list. This list is the list inside of the larger list. Finally, we will use a print statement and print out the row, followed by the column, followed by the value at that row and column. When we run this code, you will notice that each line in our console shows the row and column, and then the element at that row and column. I hope that these examples gave you some clarity over the use of programming constructs like 2D lists and double for loops. If you have any questions or need any clarification, feel free to post to the course Q&A forum, and I will be happy to clarify any questions you have. In the next lecture, we will learn about dictionaries in Python.